Okay, so going through some exam style multiple choice questions, mainly on the concept of algebra, but there's a few variety of questions here which we've got. I think it's four. Yeah, we've got four questions here that we're going to go through. And the aim of these is just to try and get them out of the way as quickly as possible. And they're multiple choice. They're only worth 1 mark each. But at the same time, we want to make sure we're doing them right and accurately. So the first question here, we've got to figure out whether this function is odd or even. Obviously, you've got four options. The reason I've crushed up this last one is because it's a zero function and nothing like that exists. So we can, cancel that out straight away. Helps clutter up the mind a bit. So how do we figure out what the function is odd or even? So if we have the function f of x, what we do is we put in f of negative x, right? We test that. And if the output we get is negative f of x, then it is odd. If the output we get is just f of x, then it's even. And if it is neither of those, well, then it's a neither function. Okay, so testing this one now, let's put in f of negative x is equal to negative x squared minus 1 over negative x. Now we know that when you're squaring a number, it doesn't matter if it's positive or negative, the output's going to be the same. Right? 3 squared or negative 3 squared is the same thing. For example, this is just x squared minus 1 over negative x. Now this negative in the denominator we can put to the front, so that's just equal to negative x squared minus 1 over x. Now if you have a look, this part over here, that is where our fx is. So this is basically equal to negative f of x. Right? And since it's negative f of x, that means that we've got an odd function here. So our answer is B, it's an odd function. Okay, moving on. Second question. Which inequality defines the domain of the function fx is equal to 1 over root x plus 3? So we've got two limitations here. Okay, first one is that we've got this in a square root. Okay, square root meaning that the x plus 3 has to be greater than or equal to 0. Right? Just looking at the square root. But the other condition is that this is in the denominator. And if something is in the denominator, it cannot be equal to 0. Right? Because then we get an undefined function. So instead of x plus 3 being greater than or equal to 0, we're going to have instead x plus 3 has to be strictly greater than 0. Right? It can't equal 0 either. If it's just a square root, then it can equal 0. But since it's in the denominator, we can't have that equal 0. So that means that x, if you move the 3 to the other side, x just has to be greater than negative 3. Okay? Which is part A here. So don't get confused with options A and B. Very similar, but we need to make sure that, we understand that it can't be equal to 0 because it's in the denominator. The third question, which expression is the correct simplification of this thing here? So how do we simplify that? Now, this is a bit of indices more than in the specific algebra space, but we've got 9 to the power of 2x over 3 to the power of x. Let's have a look. So what we can do here is, we know that 9 is also a power of 3, right? 9 is 3 squared. So you can say this is just 3 squared to the power of 2x over 3 to the power of x. And then from there, what we can do is we can expand this. So when we're doing a power to a power, we multiply the powers together, right? So that's just equal to 3 to the power of 4x over 3 to the power of x. And now we're dividing indices with the same base. So when we're dividing, that's just equal to 3 to the power of 4x minus x, which is equal to 3 to the power of 3x. So our answer becomes option D here. Okay? Simple, speedrunning it. Last question, what is the reciprocal of x plus 1 over x? That we want to find the reciprocal of this entire thing, right? And to do that, we need to get it into one whole fraction. Okay? So right now we have x over 1 plus 1 over x. So we can find that we can use the common denominator as x. So let's multiply this up and down by x. X times x becomes x squared. 1 times x becomes x. So now we have x squared over x plus 1 over x, which you can put under one fraction, x squared plus 1 over x. And what reciprocal means is that we're just flipping the fraction. So the reciprocal would become x over x squared plus 1, which is option D again. There you have it.